Okay, so in this video I'm going to go over a work energy problem. So the problem reads, an object with a mass 100 kilograms is moved in outer space. When it is at location 14, -28, -7 meters, its speed is 10 meters per second. A single constant force, which is given as 190, 440, and -160 newtons, acts on the object, moving it to location 20, -33, -10 meters. So the question is, what is the speed of the object at its final location? Here's your given information, all underlined in green within the question. And for this particular problem, we're going to choose our system to be the object of given mass 100 kilograms. That's it. And let's go to how we're going to get our solution. First off, we're going to start with a fundamental principle, which is the change in energy equals work, which then you can expand to the final energy minus the initial energy equals work. And because the system is only the object, the kinetic energy is the only energy that's going to be taken into consideration. So, because kinetic energy is the only energy we're going to use, we can use this definition. Kinetic energy equals the energy minus the rest energy. And then we can expand the E final minus E initial. And after expansion, doing a little algebra, you can cancel out the rest energies. Once the rest energies are canceled out, you'll end up with the final kinetic energy equals the initial kinetic energy plus work. And here's another basic definition, but for work is the dot product of two vectors. So you get a scalar quantity. So F vector dot R vector equals work. And that can be expanded to Fx delta x plus Fy delta y plus Fz delta z. And here work is expanded. Now let's expand the kinetic energies. I showed you one definition of kinetic energy, now here's another one. This is an approximation that kinetic energy equals 1/2 mv squared. So replacing kinetic energy final and kinetic energy initial with 1/2 mv squared, you'll get this. And then you go through more algebra steps. Multiply both sides by 2 to cancel the 1/2. Then divide by the mass to get v squared on the left. And then finally, your general solution will be v equals the square root of 2 times the initial kinetic energy plus work divided by the mass. And from this, you can plug in your initial values, do your calculations, and get a numerical value for v.